Good morning. It's very hard to follow up on a talk like Jimmy's. Let me try. Okay, so I'm going to talk today about social search. And I'm, as Ilya said, I'm from Microsoft Research in Silicon Valley, Mountain View. So walking distance to Google and LinkedIn and a short drive to Twitter. So the outline of my talk is I'm going to talk about social search in Bing, walkthrough of the product, and I'm going to give you a deep dive into two technical morsels. And then I will also talk a little bit about the limitations of social signals, because maybe they're not all they're hyped up to be. Okay, so the first part is social search in Bing. Just as I was boarding the plane, I discovered this news release on TechCrunch. As you might know, we have a number of partnerships with social network companies. Microsoft has partnerships with Facebook, with Twitter, Quora, Foursquare, Gogobot, and a host of others. 6 days ago, we announced that we are also partnering up with LinkedIn to serve up their content network of professional connections. Okay, so I should first define what do I mean by social search in Bing. I mean two different things. One is to use search to surface social media content across those different social networks. So in the case of tweet, it would be tweets, answers in Quora, Foursquare status updates, blog posts on arbitrary blogs, including private content, like the posts your friends have posted to Facebook, including things like photos by your friends. That's very powerful. And the other part is that we are using social information to improve normal algorithmic web search. So results might get promoted if your friends on Facebook like those web pages, or web pages that are trending on Twitter will get promoted. Okay, so let me first show you an example of impersonal search. So here I'm doing the query crowdsourcing. And you can see on the right-hand side, bottom right, we already have some content from a social network. These are results from Quora. Quora is a question answering service, community question answering. But I am not logged into Facebook. And so Bing will throw up a connect page, a little widget there, that allows me to connect my Bing experience to my Facebook account. And if I do this, then you can see on the top right, I'm logged in now. And I see things that my friends have posted on Facebook related to crowdsourcing. So Edgy, who is now at Google, was talking about what is the industry doing with crowdsourcing, forwarding an article in the Foreign Policy Journal, interesting. Raman Chandrasekhar says something else, Carlos Castillo says yet something else. So this is content that you could not surface on Facebook itself today. If you do a search on Facebook, you can search for people, you can search the web, but you can't search Facebook itself. But try it. I should mention, if you are going back to your hotel room and try it, you will not have much luck. I don't know why, but it's not actually working in Moscow. Maybe it's limited to the US. Okay, so here's another example. Again, I'm connected to Facebook and I type the query Hong Kong photos into the browser. And I get back a photo taken by my friend Nick Creswell of the skylight in Hong Kong. Now you notice that the photo doesn't actually contain the words Hong Kong. We get this not by image recognition, but by an annotation that he left on the image. So it's still normal text search. Here's another one. I'm issuing the query Moscow and I get Facebook posts about Moscow. I get a photo by Ricardo. But interesting enough, I learned that my friend Dmitry Petrov was born in Moscow. So if I'm planning a trip to Moscow, I know whom to turn to, a trusted friend, to get recommendations on what to do and where to go on that trip. Okay. Here's another one. Again, I asked for Moscow, and I get results from Gogobot. Gogobot is a social networking site that assists in trip planning. It's a social result. It's not personal. While there might be a friend network, we don't use that relationship, so we surface posts by all Gogobot users. Okay, so another social network we surface is Foursquare. Again, Foursquare does have a notion of friends. I should explain what the service is. Foursquare is a location-based service. You go to a place and you check in at that place using the GPS receiver in your cell phone. And you're incented to do this by getting possibly a discount at the establishment and kudos from like little virtual badges from Foursquare, and you let your friends know that you are there. You also have the opportunity to rate the place. And so those postings attached to particular locations is what we surface here. So this query here is Il Fornaio, and somebody is commenting on the Il Fornaio in San Jose, that it has a big door and that you should try the vodka. Okay. Another social network we surface is Quora. Quora is a community question answering site, very much like Yahoo Answers. People can post questions, other Quora users can leave answers for those questions. Answers can be voted up by the community, so there's a notion of relevance. And people can also suggest better ways to answer things. So answers are editable or improvable by the community. Again, we surface public content. We don't make use of any friend network in Quora. Here the query was Hong Kong views, and I see recommendations by a number of people where are the right places to go to get a good view of the Hong Kong skyline. Okay. Furthermore, we surface random blogs. So here the query is social network. We get information about the movie, the social network, and the cast of the movie, but we also learn from various film critics who have commented on the movie. So here, this is on Slate. Somebody saying that the social network wants to be a social satire, a miniature commentary of manners, and so on. And then another one here from the Tampa Bay Times. Okay, and finally we surface both tweets and people's cloud score. So here again the query was social network. There's a guy called Josh Young who has a tweet about the movie, about a social network, not the movie, an actual social network. And we learned that this person has a cloud score of 50 and is competent in applications and Facebook and security. Cloud, in case you don't know it, is a company that tries to rate the competency of social media users in particular areas. Okay, then we also use social signals to improve normal algorithmic rankings. So, for example, here I issue the query CACM, and the second result on the left is a link to the communications of the ACM, which is what I intended. And this result was promoted because 3 of my friends on Facebook liked it. Marcus Fontura, and this looks like Brian Davison, and I guess it's at G again. And that's personal to me. This I get because I am logged into Facebook right now. By comparison, no, this is another one, personal. I issue the query ECIR 2013. I get a bunch of results. I also learn that 2 of my friends have liked the ECIR 2013 page on Facebook. So this is different from a web page now. They liked the Facebook entity ECIR 2013. So that's why it surfaced on the right-hand side. And if you click on that link, it will get you to the ECIR homepage. Okay, here's a query for Inauguration Day. I did those screenshots a while ago around the time of the US presidential inauguration. And you'll see here the second post is on the Washington Post, an article about the oath of office. and there's a little arrow next to it and tells you that this topic right now is trending on Twitter and Facebook. They are in the public Twitter posts and in all the different private Facebook posts, a lot of articles talking about the inauguration. So this result is non-personal, right? It includes data outside of the network of my friends, and I can't see any of the individual posts about it. But I do learn that in aggregate people are talking about it. And then on the right-hand side we have again personalized results. Okay, one very important vertical is people search. About 10% of the queries we see on Bing are about people. And they fall into two categories, celebrity queries and everybody else. Celebrity queries are fairly easy to handle, right, because there's a limited set of celebrities. Everybody else is rather hard. And so one proposition is that we can use social networking information to help you find the Ben Smith you're looking for among all the millions of thousands of Ben Smiths in the world. So one thing we do is we actually allow people to take ownership of their own identity. When I type my own name into Bing, because I am currently logged into Facebook, Bing realizes I'm asking about myself, and it tells me, well, I mean, here are a bunch of pages that are about you, and it offers me to tag my own pages, or tag web pages that talk about me and say, yes, this page is about me as opposed to the other Marc Najork. So if I go into this mode, I see all the pages that might be about me. This one is already tagged. I can untag it. And then I don't see any untagged page on here, but I could go and say, this page is about me. It's not yet tagged. Please tag it. And I can also go out and tag the pages of friends. So for example, it suggests that I might go out and tag pages about Jeff Dean, because Jeff and I are connected on Facebook, or Krishna Bharat. Okay. So just to show you what happens if I do this for a different person, here's a query for Ricardo Baeza Yates, and we get some information about him. And we also see that he has been tagged in Bing with the following web pages, and I could go out and apply more text to his name. I think he must have done this himself though. Okay. Here is another one. This is Andrew Tompkins. And you see that we, among other things, surface his LinkedIn page. So we can see his photo, his LinkedIn account, his location, his education, his social network, and so on. If we hover over the Experience button, the view changes, and we see his education and his current employment. Okay, so then another category is celebrity search. Here's a query for Britney Spears. No talk is complete without a bunch of Britney Spears slides. So we see news articles, that's non-social. We see a bunch of images. We see that one of my friends liked a Britney Spears page. Interesting. I wonder who that is, and we can't actually on the screen see the little thumbs up. We do get information from both Wikipedia and Freebase. Freebase is a big database of factoids about Britney Spears. So for instance, we learned that she was born in 1981, I believe, that her spouse is Kevin Federline, and that she has 2 children. No, different spouse now, okay. All right, and we see her presence on social networks. So she has a Twitter account, a Facebook account, and a cloud score of 96. The scale goes from 1 to 100. So she must be important. And then we see something about her music and related searches. One thing I want to point out here, the related searches are smart in the sense that the system understands that this person here is not just somebody people search for, but that there's a family relationship, that this is a sibling. So there is semantics behind related people searches. Then on the right-hand pane, we see Britney Spears' Twitter account. We see that she has, in a particular domain, cloud about Lady Gaga, about Miley Cyrus and Brazil, whoever. Is this a country or person? I don't know. And then the latest tweet was, this was as I said, taken in January. Tocom Dengue, Mulatto, whatever, something Brazil. We also see that a fan has created a Twitter account to talk about Britney Spears news. And we see a bunch of tweets by this fan. And then we get information on Quora, this community question answering system, about all things related to Britney Spears. Here's another celebrity, Barack Obama. Again, we get algorithmic search results. Some friends have liked Obama. We get Wikipedia information. We get statistics out of Freebase. So for example, we learned that he is worth $11.8 million. So much for soaking the rich, right? He has written a number of books, and then people who searched for Obama also searched for Romney and for Michelle Obama, for George W. Bush. And again, the system understands that Michelle Obama is his spouse. And on the right-hand side, we see Facebook posts relevant to Barack Obama. People in my network talk about him. And we see that a number of friends have not only liked Obama on the web, but also have liked Obama on Facebook. If we were to click onto that thing, we would get to Obama's Facebook page. And then scrolling down on this page, we see that he is also tweeting, has a rather high cloud score, 99, about as high as it gets. And here is his latest tweet. This was, again, in January. We also see that there is a White House account, so the system is smart enough to understand that the Twitter account, the White House, is, controlled by Obama, and get the latest tweets from that account. And moreover, we surface content from Google+, so here are a bunch of Google+ posts, again about Obama. I should mention, since we do not have a partnership with Google for reasons I don't understand, these are public posts, right? These are not personalized. Okay, so just to summarize what I've said so far, we surface, time check, yep. We surface social content from Facebook, Twitter, Quora, Foursquare, Cloud, LinkedIn, Google+, Gogobot, and random blogs. And here are a number of social search scenarios where social information can actually make your experience better. I think the killer scenario is people search. For celebrities, you get a direct, in quotes, connection between the star and the fan. You can get to the celebrity's Facebook page and read about what they're doing right now. You can view their tweets, and so on. For non-celebrities, because we can see the social network information certainly on Facebook today, and presumably very soon on LinkedIn as well, thanks to the partnership, we can recommend people who are relatively close to you in your social network to resolve name ambiguity. And that is very, very powerful. If you ever search for somebody with a common name, it's very hard to find that particular person. And then the other approach is that we do crowdsourcing on Bing to disambiguate people. Another scenario is travel planning. And there are, again, two varieties, a public one, a private one. One is that you get grassroots recommendations. And of course, the grassroots might actually be astroturf, that the companies themselves go out and maybe pay somebody to do favorable reviews of their properties. One way to have a bit more trust is that you surface information from people you actually know. You could then offline go and really ask the person. So in the query Moscow, my friend Dimitri is from here. And so we know if somebody has traveled there, and we also know if they have ever resided there. Another scenario is local search. Restaurant recommendations, retail recommendations, recreations, and again, both from public sources, people you don't know, and from the friends you know and trust. And then another one is informational queries. I think they're the most compelling one is going to Quora and surfacing questions that have been asked about what you're interested in and answered by experts. Oops. How do I go backward? Okay, so I'm now switching gears. So I'm going to deep dive into two select technical details. And I should mention, these are two things I worked on. I make no claims if they are deployed in Bing or not, if I want to keep my job. So I'm not making any claims there. The first one is I'm going to talk about how to compute affinity between two users in a social network. And what I want to measure is not only how short the path between two users is, say in the Facebook graph, but rather how robustly they are connected, if there is more than one path between me and the other guy. And it should be efficiently computable. Again, I mean, we need to do this in sub-second time frames. So I think our service guarantee is like 0.2 seconds or so. And the example application here is people search for non-celebrities. Okay, so here's a candidate measure. If I have a social network, a graph, and given two users, two nodes in that graph, what fractions of edges in the graph can I delete before those two users become disconnected from one another, before they fall into two different connected components? A higher value of the fraction of edges I can delete indicates that those people are more robustly connected. In the extreme case, if I can delete all the edges and they're still connected, they are the same person. And on the other extreme, if they are not connected to start out with, then I mean, there's just no way I can direct them to one another. Okay, so let me give you an example. Here's a graph. Doesn't look like a social network, but just an example graph. And there are two nodes, A and T, and I want to compute how robustly, what is the affinity between A and T. So I'm now going to start to delete edges in the graph. And there we count up. This graph has 50 edges, so I deleted 2 edges, 3, 4, 5, 6, and so on. I'm deleting. I've deleted about half the edges. So once I delete the 28th edge, a component in this graph becomes disconnected. The components C, D, and F. But A and T are still connected. Continue deleting edges, a second component becomes disconnected, O, Q, and R. We have now deleted 30 edges, 31, 32, and boom, A and T just became disconnected. At 33 edges deleted, so the affinity value between those two nodes is 0.66. Okay, and I mean, you can imagine that what you really want to compute is how many edges do I have to delete in expectation over all the permutations of edge deletions for this to happen. Okay, so this is expensive to compute, so we would like to have an approximation algorithm for it. And it would be nice if we can do all the heavy lifting offline, not at query time, because we want to have this sub-second guarantee of being able to answer a query. And of course, we want to run this online, not just for one other person. We want to run this for all the candidate users that are returned by a search. So the offline phase of the algorithm consists of computing the connected components of the graph, say using union find for various levels of edge deletion. For every vertex we record for a given number of deleted edges, its connected component ID, this could be the numerically smallest vertex in that connected component, some representative. And then we're going to delete some more edges and repeat the algorithm. And then the sketch of a particular vertex is a list of all the connected component IDs for the various levels of edge deletions. Now, if you're familiar with the union find algorithm, you build up a tree of a tree relating all the vertices in the same connected component. And union find actually allows you to add more edges to a graph and run the algorithm from its previous termination point, and so you don't not need to redo work. So as an optimization, rather than deleting edges, you can start with a graph with no edges and add edges in, and then just do incremental union find. So let me try to illustrate that. Here is the same graph we had beforehand. I have removed all the edges, so the graph is completely disconnected. Every single vertex is in its own little connected component. And the first slice of our sketch vector associates every vertex with itself. It is its representative. The representative for A is A, the representative for B is B, and so on. For the level 1.0, all edges are deleted. So now I'm going to add edges back in. I added an edge between A and G, which puts G into the same connected component as A. So note down A here. Add another edge. This is the level where things fell apart, so one more and A and T are connected. You can see that vertex T at this level 0.60 is in, down here 0.66 is in the same connected component as A. And then running this to completion. Boom, we get the slice here. Okay, so that was the offline phase. There are two more optimization I can do. One is that I don't actually need to delete the edges in a uniform fashion, that I delete like 10%, another 10%, and so on. But rather I can choose the distribution of edge deletions in such a way that I optimize it for the structure of a given graph, thereby increasing the discriminative power of the algorithm. And then another thing I probably want to do is I want to run the offline phase not just once, but k times over in order to get a better approximation of the true expected value of the probability in expectation that two vertices are connected at a or become disconnected at a certain edge deletion level. And then I should also point out there are multiple variants of this algorithm. It can deal fairly straightforwardly with weighted edges. That is important, say, in the Facebook scenario where you have a measure of how strongly two people are interacting. If we are friends on Facebook, it doesn't really mean a thing. My son has over 1,000 friends. If we post on each other's wall all the time, then probably this connection is much more intimate. We really, do know each other, and therefore that edge should have a higher weight associated with it. And that's easy to incorporate here. And then, in theory, the algorithm can also deal with directed edges, but it's far more expensive. You need to use Targent's algorithm to compute that, and there's no way to amortize the result of previous computations, so it's computationally just much, much harder. Okay, let me talk about the online phase. What do I need to do at query time? I just retrieve the sketches of the two users, U and V. There's a sketch of A, there's a sketch of T. And then I count how many of the connected components of the representative in each sketch vector are shared between the two vectors. So in this case here, 64% of the connected components are shared. So that's my affinity value. Okay, so switching gears again, that was an algorithmic morsel. Now I'm going to talk about a piece of systems infrastructure. Running a bit fast here. So the problem is, how can we surface liked pages, things that were liked on Facebook in Bing? And this sounds trivial in principle, right? I mean, you retrieve all the results to a query, you rank them according to relevance, and then pages which are liked by your friends, you give them some additional relevance and boost them up in the ranking. Okay, so where's the problem? The challenging part in practice is because indices, I have to take a sip of water, that I'm not a politician. As Jimmy has explained in the Twitter example, modern full-text indices are distributed over many machines. They're sharded up. An individual index on a particular machine consists of a bunch of postings lists, one per term, and this posting list maps a term to all the documents and positions containing that term. And as I said, the index is partitioned by document in our case across many index servers, ISs. And then the front end of the indexing service sends a query to every IS containing a shard of the index, and the IS sends back results, the front end aggregates them and then ranks them and returns the 10 best results. In order to keep the network traffic manageable, I mean, any particular index server might have thousands and thousands or maybe even millions of results for a particular query. But in order to reduce the amount of traffic, each IS actually performs an initial ranking and returns only a few results. Think on the order of 5 results to the front end, which, if there are hundreds of index servers, will still lead to a substantial number of results, and then the front end can do the more detailed ranking. Okay, but what does that mean? Well, I mean, it means that we have a number of choices. Approach 0 is that only the front end has the full Facebook graph. But what that means is that the front end sends a query to the IS, and the IS, in order to surface liked web pages, would have to send all the matching results, not just the top few, to the front end. And then the front end can rank them using the Facebook graph as the likes in Facebook as one additional relevance criterion. Now that's clearly not feasible, right? I mean, if we move from sending 5 results to sending thousands or tens of thousands of results, then this would just overwhelm our network. Another approach would be to say that the front end still has a social graph, but the index servers have a special postings list. One posting per user, so users are becoming terms, and that postings list maps users to the documents they like. And in this world, the front end would send the query and a list of all the friends of the user who issued that query down to the index servers. The index servers would retrieve the results of the query as usual, and then intersect that result with the documents that are liked by the user's friends. So it looks up all the postings lists for each friend, takes their union, and then intersects that union with the resulting documents. And that's a perfectly reasonable scenario. It turns out that the list of friends can be very large. Facebook allows for up to 5,000 friends. So the queries would become very large, and our system is actually not laid out for sending such big queries down to the index servers. This would just, again, overload the network. Okay, so can we do better? Another strawman scenario is to say that the index servers have a special postings list, again, one per user, but this postings list maps the documents maps that user to the documents liked by their friends. So now instead of having to send down a list of all the users to the index servers, we just need to send down the identity of the user who issued the query. The problem with that solution is that the index size explodes. I mean, you have a lot of friends, and those friends might like a lot of web pages, and so it just becomes unmanageable. But the other problem is that the friendship graph changes actually rather fast. The likes obviously change as well. And all those changes would have to be propagated to all the index serving nodes in the system. And again, that's not really practical. So the proposed approach here is to have a hybrid approach where we have a special postings list, again, one per user, that maps users to actually, sorry, this is not the final solution. This is, again, another strawman proposal. The index server has, again, a special postings list mapping users to like documents. And then it has another list which maps users to their friends. You might be able to implement this as a postings list, but you will not be able to reuse all the code for manipulating postings lists. And now the front end only needs to send the query and the user ID to the index server. The index server first expands the user ID into the list of friends using this data structure here. And then it looks up all the documents liked by those friends and intersects this with the documents responsive to the query. The problem with that solution is that you still have to propagate all the friendship changes in the entire Facebook graph down to every IS. And so here is the final solution, a hybrid approach between approach 2 and approach 3, that you divide the user base of Facebook into two classes: highly connected users, influencers, people who have many, many friends, and then all the rest. And of course, the rest is the majority, right? Most people have a moderate number of friends, but not 5,000. And so now the index server has a mapping for all the HCUs to their friends, as in the previous approach. It has again a special postings list, one per user, mapping each user to the documents they like. Don't need the expansion of documents liked by their friends. And then if the user who issued the query is a highly connected user, then the front end would send the query and just that user ID to the index server, and the index server would treat it as in the previous example. And otherwise, the front end can send the complete list of friends, because by definition it isn't that long. And then we can deal with it as in approach 2. Okay. Switching gears again, I want to talk briefly about limitations of social search. And again, I should stress here, all the views expressed here are mine. They do not represent Microsoft's view, and this is very true, particularly for this part here. Okay, so there are two basic assumptions in social search. Why is it a good idea? Assumption 1 is that user-generated content is valuable. There's the whole meme of the wisdom of crowds. And assumption 2 is that you are similar to your friends, that you share traits or preferences, you are influenced by their opinions, you trust them. Both of them are somewhat true, right? But there are limits. Most links in social networks are actually fairly weak. My teenage son has, I looked today, 1,098 friends, and I highly doubt that he has an intimate relationship with all of them. And many postings you find on social networks are drivel. Here is a cup of coffee I had this morning. Okay. So here is an example of attesting to the power of social information. This is a study which was done by a number of people, including my colleague Thora Greppel of Microsoft Research Cambridge. They took Facebook likes information for 58,000 users who opted in, and who, as part of opting in, filled out a personality profile that allowed the researchers to measure their intelligence and their emotive state and a bunch of other parameters. And then these people tested whether or not they could infer just from the Facebook's likes of those people what are their personality characteristics and psychometric traits. And it turns out that likes are highly predictive of attributes and traits. So for example, they were able to, with accuracy of 93%, to predict the gender. The measure here for the left column is area under the curve, which is roughly speaking the probability that if you're given two people, one from each class, one male, one female, that you can correctly distinguish them. Sexual orientation, I mean, for males, 88% distinguishing between straight and gay. That's pretty amazing. 85% political persuasion, whether they're Democrats or Republicans. 82% religion. Very high for racial identity, and then somewhat lower for things like drinking or drug use or cigarette smoking. It gets more complicated for things on the psychometric side. On the right-hand side, we have numerical information. Their measure of accuracy was the Pearson correlation coefficient between the two numbers. So for age, they were able to predict it with a correlation of 0.75. For things like, say here, intelligence, they were able to predict it with a correlation of 0.39. It's worth pointing out that the accuracy of the test itself is only 0.78. If you give the same IQ test twice in a row to the same person, I mean, they only correlate, the two tests only correlate at 0.78. And for things like satisfaction with life, it's, I mean, even worse. It's a very subjective time-variant test. So anyway, that demonstrates that there is a lot of signal there, right? Well, not really, right? Because those likes, they're not really social information. I mean, these are things that people did on Facebook, but the researchers who did the study could have instead used those people's query history or their browse trails, which is a much denser signal. And of course, a search engine like Bing or Google or Yandex has this information. But they do have query information. So social networks are a great source of information, but they're not the only source. Here's another one. This is data I cribbed from a study by the Pew Institute. Pew is a researching company that surveys internet use in the United States. This study was actually about the use of online photo sharing sites, but it has a number of interesting demographic factors. So this graph shows you the likelihood that a person who is already on the internet will use a given social service. So 66% of internet-enabled Americans use Facebook, 20% use LinkedIn, 16% use Twitter. Twitter is growing pretty fast, but it's, I mean, a distant third here. Here is a breakdown by gender, age, income, and education for those three services, Facebook, Twitter, and LinkedIn. You can see that gender is fairly uniformly distributed across the two networks. Again, those numbers here mean what fraction of the internet-enabled population is on a particular service. So for Twitter, 17% of internet-enabled males are on it, but only 15% of females. Age distribution, you can see that Facebook is a young medium. Young people are much more likely to be on it than older people. Twitter is an even younger medium. I mean, the 18 to 29-year-olds completely dominate. You're much less likely to tweet if you're in retirement age. By comparison, LinkedIn is solidly middle age. If you're between 30 and 65, you're more likely to be on LinkedIn than if you're either younger or older. And that makes sense, right? Because these are people who are looking for jobs, right? If you're retired, you're probably not looking for a job, and if you are still in college, you might not be looking for a job either. Income distribution, sort of fairly uniform on Facebook. On Twitter, also pretty uniform. Actually, the somewhat wealthy demographic is slightly more likely. and I can talk offline about the sampling bias in this study. I don't actually quite believe that part. LinkedIn is heavily geared towards wealthy people. If you are making over $75,000 a year, you're much more likely to be using LinkedIn. And then finally, education, you see the same pattern, that LinkedIn users are far more educated than Facebook and Twitter users. That makes good sense just based on the age distribution, right? When people are further down in the life, therefore they earn more money and have higher educational achievements. Okay, so I'm gonna have some thoughts on tweets and hide here. Okay, so tweets, there is a staggering amount of data there. According to the Library of Congress, there is now over 200 billion tweets out there in the collected corpus. And again, according to LOC, which differs from the number you quoted, there are more than 500 million new tweets per day right now. The LOC release was from January. I think your number was 400,000. Okay, so some of those tweets are really highbrow. Here's Bill Gates talking about global childhood mortality and what he's doing about it. Wonderful. It turns out this is the exception. Most tweets are like that. How will I spend my evening? Let this soak in here. I did a study where I went through 2,500 tweets and looked at every single one, and the things you see there, I had to, to wash with lots of soap afterwards. So a research problem is automatically identifying high-quality tweets, which raises the interesting question, what exactly is a high-quality tweet? And it turns out you can't get humans to agree on that. And I'm ready for questions.